Good afternoon, everyone, and a warm welcome to everybody. Welcome to this session on renewable energy value chain and global trends. And without wasting any time, I'm going to hand over to Mr. Linduku Terblanche, who will do the introduction of our speakers. And thank you. Over to you, Mr. Terblanche.
Thank you very much, Luntu, and welcome everyone to one of our installments of webinar series where we will be looking at the renewable value chain and opportunities for South Africa's energy transition. And as we all aware that across the world, renewable energy offers an opportunity for countries to reduce their consumption, more specifically on fossil fuels, and increasing the energy security and diversify energy systems. So South Africa is no exception to that. While we have successes, in fact, it was one of the, at some point, we were named as one of the best programs that has ever been at that time been done in terms of procurement, where the renewable energy independent power producers was introduced, and it was one of those best procurement processes that we have ever done. And also the country only features in the downstream segment of the value chain, as there is limited domestic production as well as manufacturing of renewable energy components. So South Africa can leverage its growing renewable energy capacity to expand into upstream segments of the value chain to enhance renewable energy components manufacturing. So to do this, it is important to understand all the segments of the value chain. So today's webinar will be giving us an insight into the renewable energy value chain to help us understand the entire renewable energy value chain, to assess where opportunities and risks lies for South Africa. And the discussion will be done in two parts. The first part will be done by Lerato Munaisa, who is an analyst in GTAC, Capital Project Appraisal Unit. And Lerato holds an MPhil in industrial policy, as well as has some experience in terms of working on climate policy and low carbon technologies. And she will then set the scene in terms of highlighting what are the global renewable production as well as price trends. And then once she's done, she will then allow us, she will then be followed by Mr. Ulrich Terblanche, who's an expert analyst for renewable energy at GreenCape, and focusing on market intelligence in the energy sector. Mr. Ulrich holds a master's degree in sustainable energy engineering and has extensive experience in the renewable energy sector and has been active in the industry for decades. And he will be presenting on the work that is done by GreenCape on the South African renewable energy landscape, and it's exploring and its projected growth. He will also be discussing the renewable energy component manufacturing, exploring the key drivers and identifying the barriers that it's keeping us not achieving our main objective of also participating on the upstream of the industry. So without any waste of time, I would really like to ask Lerato to come in and set the scene for us. Lerato, And then once you are done, Lerato, with your part, and then I will also ask Mr. Terblanche to then come in and take us through his part of the presentation. Over to you, Madam.
Thank you, Lindo. Let me share my presentation here with you. Full screen. Can you see my slides clearly?
We can see it.
Yes.
Still not on the presentation mode.
Okay, wait, let me stop sharing and then have it be on the correct screen. Apologies for that. I need to move this here. Cool. Okay. Can everyone see my screen?
Not yet. Yeah.
Yes, we
see it
can.
now.
Thanks, Lerato.
Okay, great. So I'll be taking you through a renewable energy value chain and what the global trends show us. So over the last 2 decades, renewable energy installations have skyrocketed, growing by over 400% since the early 2000s. This growth has been largely driven by technological advancements, falling prices, and economies of scale. Wind and solar have emerged as the fastest growing renewable technologies, growing from virtually 0% of total electricity generation in 2000s to 8 and 7% respectively in 2024. The IEA expects that wind and solar energy will reach up to 30% of total electricity generation by 2030. Renewable energy policies, targets, climate policies, emissions reductions commitments, as well as the concerns around energy security and demand will likely be the key drivers for rapid renewable growth going forward. Now I want to focus in on renewable energy installations and their projections. Looking at the chart on the left, it shows that global renewable power installations in 2021, the targeted capacity by 2030, and the target capacity as per IRENA's 1.5 degrees Celsius scenario. This chart shows that in 2021, solar and hydro and wind were the leading renewable energy sources globally. In order to reach the targeted capacity by 2030, global solar and wind installations need to double from their 2021 levels. To limit global warming to 1.5 degree above pre-industrial levels, renewable energy would need to triple, rising to up to 10.8 terawatt by 2030. The chart on the right shows the targeted renewable capacity by technology and by country. Globally, according to RE Global's 2022 megatrends, solar and wind are expected to lead renewable installations by 2030, with the Asia region seeing the largest increase in renewable capacity installations, followed by Europe. In sub-Saharan Africa, renewable installations are expected to reach 140 gigawatts by 2030, with hydro and solar power leading this growth. Now, I want to focus in on the fastest growing renewable energy source, solar power. Here, I will be discussing the components as well as the production and price trends. Now, focusing on solar power consists of four core upstream stages: polysilicon production, which converts purified quartz into solar-grade polysilicon; ingot and wafer manufacturing, where this polysilicon is then melted and solidified into ingots, which are then sliced into thin wafers; cellular fabrication, which entails the wafer being chemically textured to reduce friction and to improve light absorption; and lastly, module assembly, which is the process where all the cells are assembled together and are interconnected and laminated into full PV modules. Now, in terms of global solar power production, China is the leading global producer of polysilicon wafers, cells, and modules, making up 80% of global manufacturing capacity of these components. This is shown in the chart on the right. According to the IEA, China is expected to remain the global leader of solar power components into 2027. And while this lead is prominent, India and the United States are also expected to increase their manufacturing capacity across all these components by 2027. Now, solar energy, like I said, is the fastest growing renewable energy source. The chart on the left shows installed capacity over time, and in 2020, global renewable capacity was less than 2% and this has now increased to over 1,860 gigawatts in 2024. China leads renewable installations since 2025, increasing its total installed capacity by over 600 gigawatts in the last decade. A large contributing factor to this rapid expansion of solar power has been the dramatic fall in solar panel prices. The chart on the right shows that solar power panel prices have fallen from a high of $11 in the 1990s to less than 3 cents in US in 2023. This has been due to large investments in solar panel manufacturing in China, technological improvements, government subsidies, and policies which support R&D and supply chain advancements. The fall in solar power prices has made it one of the most cheapest source of electricity in many parts of the world, including South Africa. Moving on to the second fastest growing renewable energy source, wind power. Whether located onshore or offshore, wind power production shares the same fundamental structures. The production of wind power turbines is complex and includes over 800 components categorized into the following shown in the image on the left. The first, its blades, which are made from fiberglass reinforced plastics or fiber composites or a mixture of both. The nacelle, which includes a gearbox, brake systems, and power electronics. Towers, mainly manufactured from steel and concrete to elevate and support the wind turbines. And then the foundations, which anchor to the ground or the seabed in the case of offshore wind. And lastly, electronical systems that support the turbine, including copper cabling, transformers, converters, and switchgears. Now, towers, blades, and nacelle components are the biggest cost contributors of wind turbine production. The chart on the right shows the breakdown of wind turbine capital costs, and according to Romax Technology, nacelle, towers, and blades account for 80% of the capital cost of wind power generation. This is because these are the most material-intensive and technologically complex components in wind production. Concrete, steel, aluminium, copper, and rare earth metals are the most prevalent metals in the production of wind power components. The chart on the right shows that steel and concrete are the largest mineral inputs, particularly for the towers and the foundations, while copper and aluminum are the second largest due to the structural component, cabling, and wiring. On average, these metals account for 25 to 45% of the total cost of wind turbines. And according to S&P Global, as well as the IEA, rising metal prices and supply shortages have placed pressure on the production of wind power since 2020. Since 2020, steel prices have increased by 50%, copper by 60%, and aluminum by 80%. And this has led to an 10 to 25% increase in the cost of wind turbines since 2020. The chart on the right shows how metal prices have slowed down wind power growth since 2020, with growth rates falling from 15% in 2020 to about 13% in 2023, while overall capacity has steadily increased since the 2010s. The chart also shows that the slowdown in new wind power capacity, despite the slowdown in wind power generation, the trajectory has remained upward for Europe, the United States, and China. These are the global leaders in wind power production. And this is due mainly to policy measures such as the Inflation Reduction Act, the Renewable Power EU, and China's new grid investments and renewable energy policies. So looking at the chart on the left, it shows where wind equipment manufacturing is largely concentrated. And we can see here that wind turbine manufacturing has grown to over 70 gigawatts in 2025. And according to Global World Energy Council, this growth has been led by expanding manufacturing in China, the United States, Germany, and Spain. The chart on the right also shows that planned wind turbine manufacturing is led by Chinese-based firms such as Goldwind and Envision, as well as some German and Danish companies, which are also planning to expand their wind turbine manufacturing facilities. Now, moving on to battery storage. Battery storage value chain begins with the extraction of critical minerals such as lithium, cobalt, nickel, manganese, and graphite. These are all essential for battery production. Lithium-ion battery chemistry is the leading battery storage chemistry in the world. Lithium-ion batteries dominate both EVs and storage systems, and these chemistries can be adapted to mineral availability and price. The image on the left shows the different components that make up a battery. Batteries are consisting of cathode, anodes, and separators. The cathode material is manufactured using different metals depending on the battery chemistry. Anode materials are composite of natural or synthetic graphite, although other materials can be used like silicon based anodes. And these are then converted into cells, which are often includes coating electrodes and applying electrolyte and assembling layers into a sealed format. These are then put into battery molds, which are assembled by different individual batteries and are integrated into components for safety and performance. And lastly, the battery pack, which includes multiple battery modes and is combined with thermal management and safety systems, as well as power electronics. So the chart on the right shows that China leads the production of lithium-ion batteries, followed by Europe. This is supported by the expanding renewable capacity in the country, technological advancements, and investment. China and Europe also lead the black mass refining, which is a process which converts recycled material into high purity battery grade chemicals. So the chart on the left shows that global lithium-ion battery capacity has surged since 2015, recording a high of 41.5 gigawatts in 2023. This is due to strong government support for the rollout of EVs and incentives for battery storage that are expanding in markets around the world. Raw materials account for 50 to 70% of the cost of battery storage, with materials like lithium, nickel, cobalt, and manganese accounting for the majority of the cost. Since 2010, the price of lithium-ion batteries has significantly declined from around $1,200 to $127 in 2023. While rising metal costs are expected to slow down the rapid price decreases we've seen in previous years, gains in manufacturing efficiency efficiency and economies of scale are projected to offset these increases. And according to the IEA, battery storage could increase by up to 50% by 2030. Battery storage plays a pivotal role in unlocking renewable energy by enabling the integration of varying sources of renewable energy like wind and solar onto the grid. For South Africa, battery storage is especially important given the country's growing renewable investment and the need to reduce load shedding and improve energy security. And now, with that said, this is the conclusion of my global overview of the energy production and price trends. I will hand over to Ulrich, who will be bringing the discussion closer to home and discussing renewable energy in the South African context. Thank you, Ulrich.
Thanks, Lerato. I just want to check, just the thumbs up. Can everyone see my screen?
Yes.
Okay, great. So as mentioned, I'm Ulrich. I'm from GreenCape, which is a non-profit organization focused on the green sector development. I'm specifically involved in the energy component, but we do cover a range of different sectors. We do a lot of market intelligence work. This specific work that I'm just going to present on now is focused on investment opportunities, and it was funded through the GTAC. It also relates to market intelligence reports that we publish on our website for those that are interested to read more about it. Okay, so the South African electricity landscape is quite an interesting tale. We have quite a long history, especially through government programs. In South Africa, we have what's called the Integrated Resource Plan, which is basically the official long-term plan of where we as a country see our energy sector going. So it highlights what kind of technology we expect on the grid, by which numbers. So it actually sets out by this year, there's going to be 4 gigawatts of this technology and 3 gigawatts of this technology, etc. So it's kind of a clear pathway for how our energy system will look in the future. It's supposed to be updated quite regularly, but currently it's in the process of being updated. So the previous one that's still valid dates back to 2019, which is quite a long time ago. But there is a draft document in process, which was the IRP 2023, but that hasn't been finalized yet. So we're still waiting to see what the final document will look like and to see what kind of projected plan. And I'll explain why that is important in just a second. A key understanding of South African market, you cannot ignore Eskom. You know, Eskom as the single utility power generation or generator. They still supply around 94% of South Africa's electricity, so it's still the biggest player in the market. It is in the process of unbundling. Some of you might know that the transmission entity has already unbundled into its own separate operating entity. It's still within the umbrella of Eskom, but it's operating in own capacity. The distribution entity will follow soon. It's expected that by next year, we should see a change.
Excuse me, Rick,
Yeah.
Sorry to interrupt, but we are getting comments on the site that your voice come and go a little bit and we can't hear you clearly. I wonder whether we can increase the sound a bit or speak closer to you.
I'll try to speak directly to the mic and also try to elevate my voice. Does that help?
Thank you. I'm sure it will. Thank you.
Okay. So what I was saying is that we already have the transmission entity that's operating separately within Eskom. What's soon to follow is the distribution entity, which is expected to operate independently probably in the next year or two. And then there's the generator entity that will be on its own. Coal power is still the major source of South Africa's electricity supply, and Eskom being the major owner of the coal power plants. That also brings some challenges. The coal power plants, or the coal fleet, as we call it, are facing aging problems. So many of them are operating beyond their lifespan. And as a result, they're becoming increasingly expensive and also increasingly filled with challenges when it comes to operating effectively. So one of the key reasons we had load shedding in the past was because of breakdowns within these coal power plants. And the reason for those are, it's not just operating challenges, it is that these plants are operating way beyond their lifespan at the moment. That has improved over time. The operation of those power plants improved, and the maintenance and the maintenance of them. However, it's important to note that the reduction in load shedding isn't just because of the improvement in the power plants, it's also because of the reduction in demand for electricity. The history of renewable energy, originally it was focused, or it was most of the renewable energy power plants we have was initiated through the Renewable Energy Independent Power Producer Procurement Program, which I'm just going to call REAP. And in essence, as mentioned earlier, that integrated resource plan, that identified the capacity of the technology we want. So that would set out how much wind and how much solar South African grid should have. And then a ministerial determination will be issued, which basically triggers a bidding window for those specific technologies. And the REAP program has gone, well, we're currently, I think the most recent bid window, as we call them, has been bid window 7, which is closing. The program itself has been mixed. There was some successes and some challenges. It has changed over time, but the principle of it has been duplicated to address other issues within the electricity network. So similar programs were run for batteries. There was the Battery Energy Storage Independent Power Producer Procurement Program. There was the Risk Mitigation Program, and there was also a gas program that was launched on the foot of the main REAP program. But the most important takeaway from this slide is just basically to understand coal is still our biggest energy source, but there has been diversification, and that was initially achieved through these government programs. In South Africa, our electricity landscape is changing or evolving rapidly, so it's important to note whatever is the reality at the moment might change in the future. Just looking at the last year, we have Eskom that's been transferred to a new department, or a new department that was created, and then Eskom transferred to the Department of Energy and Electricity. We had the unbundling of Eskom happening. We have the amendments to the Electricity Regulation Act, which suddenly saw energy traders, which is completely new to the South African market, entering the scene of the energy space. We had like I already mentioned, transmission independent, but then we have the newly announced transmission network, or independent power or independent program for the transmission lines as well, which is similar to what was done for the renewable energy lines, the renewable energy projects. These are just some key points of changes, but the list is actually significantly long, and it's expected to continue to change, because the whole South African market is evolving into a more liberalized, or differently put, a privatized market, where you have both Eskom operating, but also then private companies coming into the scene, not just for building power plants and running them, but also for building transmission lines, doing distribution lines, trading of electricity, among other new functions, which is completely new to South African landscape. From our own intelligence reporting, we highlight that we estimate that there'll be around 32 gigawatt of installed capacity within South Africa for renewable energy, and that's specifically looking at wind and solar by 2030. The form that might take depends on what happens in this changing landscape, whether that will be for large projects or whether that will be for smaller rooftop projects. The mix will be there, and the balance of the mix is uncertain. But what is clear is that it's definitely moving in the direction of private projects, that we will probably see more private projects, or independent power producers onto the network than we see through the public program, the REAP program that was had in the past. The investment opportunity, we roughly translate, so those numbers are in billions. So for the private sector, there's roughly going to be another 200 billion rands worth of investment by 2030. For the REAP, which is mostly continuation of the previous bid windows, so that's basically implementation of those bid windows, is also roughly 200 billion rands worth of investment. What is important to note is that the REAP program, although bid window 7 is at the close, no new bid windows has been announced. So there's been mention of new bid windows, there's talks of changing the structure, but as it stands today, there's no new bid window to participate in that level of government program. Then there's additional opportunity related to the growth in the sector, which is going to be the manufacturing of these components. So if this build-out is going to happen, the material needs to come from somewhere, and I think that's key to what this whole discussion is about today. In terms of the different technology growth in South Africa, the solar PV is the leader at the moment. As a technology, it's much more flexible and scalable. So whether it's a single panel on a roof of a house or a massive 100 megawatt farm somewhere in the northern Karoo, it's the same technology principle. So it's very much scalable, where wind power tends to require very large projects to be viable. So you will mostly see large projects implemented specifically for wind, and then diverse range and scales of projects for solar. The key drivers of the demand for especially private renewable energy has been the improved cost competitiveness. So for the larger projects, the cost of electricity generation in some cases has become cheaper than sourcing electricity from Eskom. So many companies are signing what they call these power purchase agreements and using what we deem wheeling infrastructure. So that is basically when you use Eskom's infrastructure to source electricity from somewhere else in the country, let's say the Northern Cape, but you have a facility somewhere in KwaZulu-Natal, then you would sign a wheeling agreement to claim that electricity generated by that renewable energy plant. So that allows a company to basically claim those green credits as saying that they are sourcing renewable energy. But if the technology is cheap enough, which is in many cases what's happening on the market, is that they can actually source cheaper electricity this way than buying directly from Eskom. So the price has been a key driver for this demand for private renewable energy. Energy security has been a driver, but more specific to storage and embedded generation, which means behind the meter. There it's especially in areas, either rural areas or municipalities that are struggling to keep the infrastructure maintained. Companies are required or are implementing their own solutions to ensure that they have secure electricity supply. It's not just for when there's an outage, but it's also the quality of supply they have to be concerned with their machinery. So they must ensure that it's the right quality of power and then that the power is reliable. And in many cases, companies are switching to having their own systems installed on site where it makes sense to do. Carbon emission reduction is a massive driver, especially for international companies based in South Africa. So the European Union requires companies to have to report on their carbon emissions, among other aspects of sustainability, but then also to set clear targets and to reduce their carbon emissions. And the consequences are that companies that usually either have shareholding or shareholders in Europe or European-based companies that have facilities in South Africa have also to report on these facilities in South Africa. And the facilities in South Africa also has to comply to these targets. So they have to, it's imperative that they do some kind of incentives or initiatives to get their carbon emissions down. And the best way or the easiest way that they're doing that is through energy efficiency, but then also accessing renewable energy. Eskom's unbundling has been a key enabler. I wouldn't say it's a driver, but it's an enabler. By having a separate transmission entity, it allows private companies to let's say, will be facilitated in a fair way onto this transmission network, which means, in a sense, they can then compete with Eskom generation. The biggest barrier that the sector is facing in the build-out of renewable energy is the transmission network itself. So Eskom noted that there's zero, or in many locations in South Africa, especially in the Cape region, there is no more grid available. And what that means is that you cannot connect large-scale renewable energy in those locations anymore. And these locations tend to be high resource areas. So through the previous REAP program, the companies was able to target the best solar resources, which is mostly the Northern Cape area, and the best wind resources, which is basically the coastal areas of the Western Cape and Eastern Cape. And as a result, so many projects have been constructed in these areas that the grid itself doesn't have the capacity to connect new projects. There are still capacity available in the northern part of the country, such as Limpopo, Mpumalanga, KwaZulu-Natal, and Gauteng. But there are different challenges there. The first being that the resources are less productive there. The second challenge is that you might have more infrastructure, or in the case of Mpumalanga, you have to compete for land with mining activity, with nature conservation, and with communities. So it becomes increasingly challenging for new projects to be connected. The way forward is basically through the newly launched transmission build-out plan, which is looking at building new transmission lines to the higher resource areas like the Northern Cape, Eastern Cape, and Western Cape that will allow more of these projects to connect going forward. It doesn't mean that the developers of these projects has paused or stopped development. They're still developing, knowing that there is opportunity in the future to connect. So private procurement, as mentioned, has been driven through these power purchase agreements. There are some limitations with what they can do. Currently, Eskom allows what we call wheeling to happen. So if you're building a power plant on an Eskom network and you're taking it off a factory or a mine is buying the power also on the Eskom network, that is completely possible, and all the policies are in place to do that. However, as soon as it's the entity, one of the entities, either the generator or the off-taker, is located within a municipal electricity network, then it becomes a little more complicated. In most cases, that the wheeling in that process is not allowed. The necessary policies aren't in place, or the municipality has what Eskom deems to be a not in good financial standing. Now, the definition of that is not quite clear, but basically what it means is Eskom wouldn't allow that wheeling activity to take place in that instance. Eskom is also working on what they term virtual wheeling, but it faces similar limitations that will only be enabled in municipal areas where there are sufficient, good financial standing, as they term it. Looking at the public procurement process, so as mentioned, there's no new bid window announced, so we don't know what the space will look like in the future. The demand for renewable energy exceeds the supply, so there's more companies looking for new renewable energy to comply to their decarbonization requirements or just to access cheaper energy. There's more companies looking for energy than there is available on the network. The private sector is growing rapidly enough that despite any government program, there will be growth. And if there is a government program, there will be enough companies interested to participate. The key barrier still being just the network itself. So even if a bid window 8 is called, if we haven't solved the problem with limited network space, it will be challenging to connect those projects in the future. There are some municipalities looking to procure or that have procured their own electricity through independent power producers. Those are the private companies. This is just a short list of some of them that made mention. Now, local manufacturing for renewable energy is starting to make sense. So there has been some challenges in the past. The key driver of local manufacturing originally was this reprogram, the government program, because it had requirements for local content. As such, companies had to source certain materials in the South African market. This did allow, or this did enable and attracted the investment into new factories. There was various experimental factories set up, such as blade manufacturing was experimented with in Atlantis or Cape Town. Similarly, various inverter manufacturers were set up. We had module assembly companies set up. For the first 4 bid windows, it was a successful growth within the manufacturing sector. But what happened then is after bid window 4, there was a delay in the implementation of bid window 5. So these factories basically saw production up to the last bid window. And then there was a couple of years where there was no demand, which forced many of them to close down. Once bid window 5 was launched or was released, it was already many years later. And unfortunately, we lost much of that capacity. But since the growth in the private renewable energy sector, the demand is becoming a bit more stable again, and that has the potential to attract new manufacturers back to the South African market. We still have manufacturing for certain components, but not for the key components. So we might not have manufacturing, for instance, for the nacelle or the blades of a wind turbine, but we have a power manufacturing company. And we have, similar for solar, we don't necessarily have a module manufacturer. We have an assembler for modules. We don't have a cell manufacturer, but we do have some of the other infrastructures, such as cables and the frames and those kind of manufacturing, component manufacturing in South Africa. So the key there is not necessarily to try to own the supply chain. It's more of trying to leverage our strengths, because it will be very difficult to compete with the likes of China, where they're best at. And another key component of this is that demand aspect. So although we have a growing renewable energy sector, the demand needs to be high enough to attract large manufacturers to get that economies of scale. And therefore, we also have to consider the export markets, because if South Africa's demand or the amount of projects we have is not big enough to support a large manufacturer, we're going to have to find ways to export that product, and therefore we have to be internationally competitive. To help with that, one of the key initiatives that was launched was the South African Renewable Energy Master Plan, or SAREM. It's worth just taking a look at that document if you have some time. It was launched earlier this year. And some of the key pillars there is to support demand through enabling market certainty and improving system readiness. It's the driving of industrial development through establishing localization objectives, aligning industrial policy and programs, and harnessing trade policy, and then foster inclusive development through establishing clear transformation objectives, fostering integration of emerging suppliers, directing activity to just energy transition hotspots, and driving an inclusive rollout of projects, and also then building capabilities through skills and technology development. So a lot of these ambitions is ongoing. It's currently being worked on, but there's still a lot that needs to be done. But the goal would be to grow this manufacturing sector, not just for the sake of it, but also for the employment opportunity, the economic growth opportunity it offers, and also to make South Africa a skills hub for the rest of the world, and maybe a manufacturing center for some of these components. So looking at those export markets, South Africa has some key benefits for being located as a manufacturer for renewable energy. We're already exporting significantly into the rest of Africa. So the graph or the table that you're seeing is basically renewable energy components that are being exported to the rest of Africa. Some of it's just using South Africa as a transfer base, so using South African ports, but the shipping basically just goes through the country to these countries. But in many cases, it also relates to manufacturing of components locally, such as battery assembly or some of the other components that we mentioned, and then shipping back to our neighboring countries. There's some key enablers in this space. So we have the South African Customs Union, which allows free trade between the likes of South Africa, Namibia, Botswana, and the other members. We have the SADC Free Trade Agreement, which includes Zambia as well. We have the Africa Continental Free Trade Agreement, which is still being worked or refined. It is an agreement that exists, but it still needs to be refined to target specific sectors. For further exports to outside of the African continent, we have the African Growth and Opportunities Act with the USA, which is currently under threat. We will see what happens towards the end of the year, but that was a key enabler for some exports to the US. That was mostly affecting the agriculture, but it had the potential to also provide an additional export market for our manufactured components. Then a very important one is the Trade, Development and Cooperation Agreement with the EU, which allows us access into the EU market. So by having these trade agreements, it allows local-based manufacturers to grow the market size, so not just feeding to South African renewable energy, but feeding the whole African continent and feeding the rest of the world, such as key markets like the European Union. The biggest barriers to the manufacturing sector, it used to be load shedding, but with load shedding having gone mostly having disappeared, hopefully continues to be the way it is this year, is uncertainty around the REAP program. So will this government program continue? Will there be local requirements? Because as mentioned, those local requirements was the key driver initially. So what's happening in the space, we don't really know yet. Local competitiveness is challenging, especially for key components. So even for some of the key components that we are supporting in South Africa, despite trade barriers such as import taxes and tax benefits and all of these different incentives in place, we are still, in many cases, not competitive with China. It's very difficult to compete with them on price. Where there seems to be a gap is more in the niche applications. There has been companies that has very smaller applications in the rest of Africa. It's a market that's potentially large, but too small for the likes of China to actually consider. So it's basically filling in those niches. I think South Africa is starting to position itself quite well there. And then restrictive international trade instruments. So the carbon border adjustment mechanism that the EU is rolling out, that creates a barrier to entry for companies manufacturing in South Africa exporting to the EU. And the reason why it's a barrier in this case is because of our reliance on those coal power plants and the big carbon emission that's been emitted by coal power plants. That for manufacturing, that's a barrier, but for the renewable energy sector, it's actually an opportunity. And that's driving these companies to access renewable energy for themselves. So it's growing the development of the wind and solar projects, this risk of limited access to the EU market. But at the same time, if you're not able to do that, and you don't have the financial means as a company to actually implement renewable energy or decarbonization, it's basically going to be a barrier to exporting to the EU. The challenge there isn't just the specific company's carbon emissions, it actually goes beyond that. It's basically the supply chain of that company. So even if the company isn't exporting directly into the EU, if they are supplying a company that is exporting to the EU. They have additional requirements to report on their carbon emissions and potentially have targets set for them. And then the US has what they call the Inflation Reduction Act. It's just a key naming thing with the many US regulations or legislation is that it doesn't actually focus on inflation reduction. The main goal of this act is to localize manufacturing in the US. So this is basically driving the local manufacturing in the US so that US can become the main exporter. So in essence, the US is positioning itself as a manufacturing competitor in the market, which will make it more challenging for companies manufacturing in South Africa. So that was a relatively quick overview on the segment. As mentioned, there's a lot of work ongoing to see how we can grow renewable energy component manufacturing in South Africa. There's a lot of work through the GTAC ongoing. So it's definitely a transforming space and a rapidly changing space. Hopefully through the South African Renewable Energy Master Plan, in the near future, we will start to see new and exciting opportunities on the market for new manufacturing. Thank you very much.
Wonderful, wonderful. Thank you very much, Ulrich and Lerato, for your presentations. Very enlightening and informative. I think before I can get into my own small questions for clarity, as well as can I then open it up to the audience to ask questions and answers? I've seen that there are some of those who are already itching. So you can just raise your hand, then we'll recognize you, and then you ask your question Adrian, you can come in.
Hi, thank you.
Unmute and come in. Thank you.
Thank you. Good afternoon. Yeah, absolutely itching. And thank you to GTAC. You guys are sending amazing information out. I note that really the discussion is around solar and wind power. Does that mean that the other options, for example, the hydrogen projects, the wave technologies, well, I suppose it's a little bit controversial, but the modular reactors, are those now sort of off the table in terms of what the direction South Africa is going in terms of what it would support?
Okay.
Thank
you very much, Adrian, on that one. And Ulrich, I think this one is yours.
Yes, thank you, Adrian, for that question. It's a very important question. So why do we focus on wind and solar specifically? In the South African market, it's largely price driven. So we don't have a lot of specific support to certain sectors. So it comes down to cost. What's the cheaper energy source that you can extract electricity from? At the moment, wind and solar has kind of won that race in that they have reduced in prices significantly over the last years, where the likes of wave energy, which is a very interesting topic, and I think Stellenbosch University has done a lot of research in that space. There, it's a cost thing. It's much more expensive to extract energy from the sea because of the rough environment that you operate in, and also around the legislation on how to actually achieve that. When it comes to hydrogen or green hydrogen, so we do have a lot of hydrogen manufacturing in South Africa, but it's not what we term green. It's not sourced from renewable energy. It's usually sourced from gas. So there, hydrogen should not be seen as an energy source. It's what we term an energy carrier. So to make green hydrogen just means that you're using renewable energy to produce the hydrogen, and then the hydrogen is that energy, almost like a carrier of energy to use in a different process. So when we say we are growing the green hydrogen sector, you're basically growing the wind and solar sector as a result, because again, those are the cheapest renewable energy sources if you want to produce green hydrogen. And that's why the talk around green hydrogen is a very interesting one. There is especially interest in the European market for it. And if we do grow that sector, it will be a product that we grow to send to Europe. And we grow that product, or that we develop that product using solar or wind energy. Nuclear is an interesting topic. Again, the cost comes to play. So depending on how you do your analysis, in most instances, if you look at the cost of nuclear, it is much higher than the wind and solar technologies. And that's why we haven't seen massive rollout. There's increasing interest in it because of the talks around modular reactors or smaller nuclear power plants, and potentially small size systems that can be at an industrial level and not necessarily at this big Kuberg type of power plant. There's a lot of talk around it because it's technology that's still being explored and tested and being developed. South Africa tends to be technology or innovation takers. So many cases, we wait for technology to be developed somewhere else and then we implement it here, which is unfortunate because I think we have a lot of potential for research and development, but that's the reality of it. So if we see significant development, especially in price reduction for nuclear, we will likely see it implemented in the future. But unless that price reduction happens, we're not really going to see it. The focus on wind and solar isn't because it's the only technology being implemented. There's a lot of bioenergy projects being developed, but again, at a much smaller scale and a very niche application. We also have hydropower, which is a form of renewable energy. There's a lot of small hydro systems being developed that you will also see. And in Africa as a whole, hydropower is the biggest growing sector. But in South Africa, which is mostly a dry country, we're only seeing small power plants being built around certain river systems. So that's just a quick summary. At the end, in summary, it's basically about cost. Which one is currently the cheapest technology? Thanks.
Thank you, Ulrich. I see Zugisa, and then Sibonejo. You will be next. Zugisa, can come in.
Thank you, Chairperson. Good afternoon, everyone. Mine is to find out from GreenCape on how are they working with government departments, if there are any, to ensure that SMMEs are also included in the renewable energy projects and procurement opportunities. Thank you.
Thank you. Can I then also take Matthew?
Thanks, Chair.
Thank you.
Thanks, Chair. Thanks for the presentation as well. I have 3 points. One is regarding China itself, on how it got to be where it is today in terms of planning and implementation. And obviously we can't leave out the scale at which they work as well. It's quite large. Is it possible to compare South Africa to them in terms of planning, the ability to plan long term, and most importantly, implementation? Where are we failing from our side? The second one, in terms of the grid itself, there was a time where we used to brag about having the cheapest electricity around. I think that time is past now. The question now, with the scale of work that still need to be done on the grid and the transmission grid, who pays for that? And does that mean now that the cost of electricity is going to surge for years to come? The last one, the Prof talked about niches in the market that's too big for China to play in, but for where we can play in. I missed that. Can maybe elaborate on that a little bit? Thanks, Joe.
Thank you very much, Franz.
Thank you so much.
Thank you.
Yeah, I just want to find out. There's a general argument that comparing South Africa with to China, there's an argument that says if we want to compare South Africa to China, because of its massive growth in terms of manufacturing of lithium-ion batteries, and also the solar manufacturing of solar panels. Their argument is that South Africa is lagging behind in terms of manufacturing of all these solar panels and lithium-ion batteries. Their argument is that it would be a futile exercise if South Africa would try to compete with China, because China is already ahead of South Africa. What is your take on that argument, which seemingly tries to discourage South Africa to also enter into manufacturing of the solar panels? What's your take on that? Thank you.
Wonderful. Thank you very much on that one. Frans, maybe, Ulrich, before you respond, let me just put in some other few questions, which might not be specific, but they're a little bit general. More specifically, when we're talking to the issue of Eskom still dominating with regards to coal power supply, and then that to me then says there's an opportunity for renewable. But then again, are we ready for that opportunity in terms of the market itself? Looking at the issue of not being, as you've indicated, that in some cases we are becoming a transferring. We are transferring these technologies. We export them, we import them somewhere and then transfer and export them to another countries. So are we as a country, as South Africa, in a position to can then manufacture some of these components? And in terms of the material that is required, do we have enough, or have we identified, maybe have we identified the material that can be used? Then we capitalize on that advantage in terms of manufacturing of those specific components, and then we will then import those that make sense for us to import, and those that make sense for us to produce, then we can do that. Maybe if you can touch on that one, I'll be more happy. And I see China is dominating a lot in this case. So for us to move, I think I'm leaning mostly on France question, whether we can shift China, and also the issue of the prices, where we seeing that the prices are dropping, but then the production is also increasing also in China. Now, is that encouraging or discouraging any newcomers in terms of the manufacturing? I will stop there. Maybe let's also take Adrian, and then you can respond to the questions. Thank you.
Thank
Adrian,
you, Chair. I'm taking a chance whilst I can. But your comment and question there leads into what I've been wondering about. Obviously, when it comes to global economics, you've got to play where you have the competitive advantage. Now, we have the world's largest resources of chromite for chromium. And unfortunately, we're probably not going to have a steel smelter shortly. But surely that which, as far as I understand, Prof, you can explain a bit more, but that is quite a important component in solar power, especially. Shouldn't there be an initiative linked in? I know mining is tricky and all that kind of thing, but for us to leverage that we've got all that chromium, and instead of sending out like we do raw minerals for China and other places to go and process for us. Thank you.
Thank you very much. Ulrich?
Thank you. That's quite a few questions. Luckily, I wrote down so I can remember them all. Yeah, just a minor correction. I'm not a prof. My actual prof will punish me if I claim that. The main thing. Okay, let me start with the first one first. So Zukiswa asked what GreenCape does with government. I think there's quite a few activities at the moment. So we are involved with the presidency of the National Energy Crisis Committee, and we have been involved there. We're also doing some work for the Western Cape government also around the space of how to basically grow green energy within the province. Specifically, we also work with different municipalities at the moment, especially on that kind of understanding that space, the new changing space of electricity and how they fit in the picture. So that's basically providing support around small-scale embedded generation regulations, helping them understand what wheeling is, how they can be part of it, those kind of assistance that we're currently doing. And we're also providing some support to the GTAC that's around exactly this work, such as that relates to SAREM on, how do we actually attract renewable energy manufacturers, but first starting with understanding what the current market situation is. So there we're working with them to trying to map out which manufacturers are there actually in South Africa, and which capabilities do we actually have before we start planning for what changes to make. We first need to understand the local market, and we're currently busy working with them on that as well. There are some other projects that we're also involved in with governments, so we're happy to get more involved. So if there's a government department that has specific needs and understanding, the way we generally operate is if you highlight what that need is around the green economy. So I'm from energy, but we also have sustainable agriculture, we have water, we have a circular economy team, and then green finance team. So if you have any queries around that, you're welcome to contact us. We would then take that information, see if we can find a funder to provide some kind of support. But yeah, we're definitely open for further communication on this topic. So I think there was the question on China, which is a tricky one. So I'm an engineer by background, so this touches more on the economics. So some of what I would say will be more of an opinion than actual fact. So I don't really think we can compare ourselves directly with China. So as mentioned, we have a different political structure. We have a different economic structure than them. So they're able to plan long-term ahead and implement those plans, whereas ours is more of a democracy where changes are to be expected in the system itself. So plans might change in the future. We are much smaller than they are, and we are much further located than they are. So what that basically implies is that when it comes to economies of scale, we don't necessarily have the capacity and the funding necessary to build massive mega factories like China is doing. And that's the way that China is becoming so cost competitive, is having this massive economies of scale in their advantage, but then also having these major market accesses to the rest of Asia and then to the US and the EU. We can compete on certain things. So that again comes down to what are our niches? What are we good at? What have we already been doing? And trying to figure out how we can support those specific manufacturing components to be able to actually compete with China. It's also, politics is dynamic. We used to be, 2-3 years ago, we were able to openly trade with the US. Now it's becoming a bit more complicated. 2-3 years ago, EU was trading openly with China. Now they're looking to diversify away from China. So these opportunities and barriers keeps on changing. It's very important for us to be flexible to adapt to those changes. So if the EU tries to position themselves to be less dependent on Chinese imports, then South Africa plays a very useful role in being that diversification. Similarly, The EU requires that supply chain tracking. So the EU's sustainability reporting requirement states that companies supplying into the EU need a traceable supply chain and report on that supply chain. And the most important component of that is you need to have an auditable supply chain. Currently, that's not allowed in China, so foreign companies cannot go into China and audit their factories, which immediately puts South Africa at an advantage that we have an open market. Any company can come and audit us or our organizations, and that basically leverages us closer to be able to trade with Europe or to compete with China. So there's a lot of these strategic initiatives that one can try to exploit globally to be more competitive than China, but it won't be on price alone. It will be on the other factors, like having a better quality product or having a more specific niche product. And that niche example, just to kind of highlight that when I talk about niches, so the niche itself is too small for China, but big for us in the sense of that especially being seen for rural energy supply. So just to put it in a blunt, simplified example, so China is interested in exporting container sizes of solar panels. But the demand in the rest of Africa isn't massive mega projects. The demand in Africa is household solar. So that positions South Africa to be a bit more niche in being able to set and develop necessary technology and packages, and in many cases their own intellectual property around solutions for households in Africa. Something simple like efficient cooking stoves. South Africa is a major producer of efficient cooking stoves in the rest of Africa. Or solar charging kits. There's companies in South Africa that develop their own systems that supplies it to the rest of Africa. China also produces these systems, but they don't have that small scale, puts on the feet on the ground kind of business leverage that South African companies has. I think that's key in some of the developments that we've seen. There's a number of battery assembly companies, many of them using South African components, except for the battery cells, that is based in South Africa, supplying into the rest of Africa. And they're able to compete with China by doing that and by having those niche applications. So not building a battery for a big power system, but rather building a battery for converting a forklift or for setting up a fridge in a community. So there's those niche applications where we can position ourselves quite well. We just have to identify what those are and then find those companies and find ways as a government to support those companies to grow. So from
yeah, you can wrap up.
Okay, I'll wrap up quickly. Sorry, we're over time.
Yeah.
Okay, so just to touch quickly on the others. So that's the China discussion. That touches a bit on what France also asked. It's not a matter of lacking behind. It's a matter of finding our key opportunity. It doesn't make sense to own a full supply chain, even if something simple as a pen is made from various components, from various locations, and a lot of different processes. We don't have to own all of that. We just have to find the one that we're good at, or the two that we're good at. ESCOM domination, so just around, sorry, I think the time is a bit short to touch that, but also on Adrian's question around the minerals. So there's a plan to what we call mineral beneficiation. We need to try to get companies not just to export the raw product, but to upgrade that product and add value to that product and then export it. Again, we won't own the whole supply chain, but if we can export the product ready for use in a component instead of just the raw material, that's a massive leap in the right direction. But that requires government support and proper initiatives. Thank you. I'll wrap up there.
Thank you very much, Ulrich. And apologies for rushing you late. The Ladies and gentlemen, thank you very much. I think that comes to bring us to the end of our webinar, and I would really like Ulrich to check on the chat. There's a question there that maybe you can respond to later on. But before we close, can I just thank Ulrich for coming in and Lerato for the presentations that they've done. We really appreciate you making time for us and also giving us this insight. And I think this is not the end of this discussion. As you can see that the discussion, we need more time to discuss this, but then again, the information that we've got, I think it's very useful for us to move forward. So thank you very much for making time, and all those that logged in to participate. Thank you for participation. We really appreciate, and we will see you on our next webinar again. I think Nobuntu, we do have another one next week, so you will get an invitation. So thank you very much for your attendance. I think that's we come to the close of our webinar for today. Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you. Bye.